So in this video we will see about GATE 2022 database questions in computer science. They have given a relation with 5 attributes and also the functional dependencies in the relation. So the question is to find the number of super keys that are possible. To find that, first of all we will try to find the primary key with given functional dependencies, and then we will extract the number of possible super keys. Okay, so for that whenever we try to find the primary key using functional dependencies, the left hand side attributes are more important. The left hand side attributes are more important. Therefore, let us start with the left hand. The first functional dependency is AB implies C. So let us take these two attributes AB and try to. Why are we taking both of them? Because we have only 3 functional dependencies and A alone cannot find anything. A identifies itself, that's it. So A cannot do anything alone. Of course, the same for B. B cannot identify anything except itself. Therefore, B also cannot be a primary key. That is the reason why we combinedly considering them. And A identifies itself, B identifies itself, A, B together will identify C. Okay, B, C together will identify D. C alone will identify E. From this you can observe that AB is able to identify all the different attributes within the relation. Therefore, we can tell AB is a primary key. So AB is a primary key. Then why can't we get any single attribute as primary key? No, we cannot get any single attribute as a primary key. A alone cannot identify, B alone cannot identify, C can identify only E. C can identify only E. And there is no functional dependency with E in the left hand side. E doesn't implies anything, and also D in the left hand side. So D doesn't implies anything. So the single attribute cannot become a primary key in this scenario. Therefore, the next possible is 2-length attribute set to become a primary key. So AB is the smallest possible number of attributes combined to get a primary key. Therefore, our question is to find the number of possible super keys. So the primary key is also a super key, which means that AB is already a super key. Okay, AB is already a super key. After AB, C, D, E, we can add any one attribute or any 2 attributes or all the 3 together. So we have 3 different positions. The presence or absence will indicate a super key. Okay, all are absent means AB, one super key. Okay, next ABC, ABD, ABE are 3 other super keys, superset of the primary key. And ABCD, okay. So here are the other possible super keys of the primary key, or the possible supersets of the primary key that becomes super keys. Okay, so here we got 1 2 3 4 5 6 7, and we also already said primary key is a super key, so this is 8th one. So total you can simply solve in this way also. Once you get the primary key, you have 3 blank positions, so each position has 2 options. One is the presence of the attribute or absence of the attribute. 2 into 2 into 2, as we have 3 positions and each position have 2 options, so we can directly tell it as 8. So these are the possible combinations and these are the possible super keys that we got. So total super keys for this question is 8.